Okay, so these are going to be the solutions for the test 2 in Math 140. Again, it's a randomly generated test, so you won't have the exact same questions as I do, but you should be able to get the answers for yours. If not, then you just email me. What is the end behavior, question 1 of this? The end behavior is determined by the leading term. And so here is our leading term. So I'm going to write that down on my piece of paper. The leading term is 3.005 x to the 235,570. Okay. And so what we've got here, okay, let me just adjust that. Okay. So that's my leading term. And what I have here is a positive number out the front times x to an even. So I look at the last digit there, it's a 0, to an even power. So if it's a positive number times x to an even power, there were 4 cases you had to know, and the end behavior is up, up. So a positive number times x to an even power gives us end behavior up, up. So I need up, up. Oh, question 2. Now, what is the end behavior of this? Now, you have to get the leading term. Now, the previous one was in standard form, and it was very easy to identify the leading term. This is not in standard form, so you're going to have to get the leading term out of all of this. The leading term is not what's out the front here, because it's not in standard form, it's in factored form. So let me write this one down. So here I have p of x is equal to negative 2x cubed times x squared minus 1 times 5 minus x times x squared minus 4 to the 5th power. Okay, so if I'm going to get the leading, if I'm going to get the end behavior of this, I'm going to need the leading terms. So I'm going to get whatever out the front. So that's negative 2x cubed times the leading term inside the parentheses to the power outside, and it's understood the power is 1, so x squared to the 1st power, times the leading term inside here. The leading term inside here is negative x. So think of that as being written as negative x plus 5 to the 1st power, so which is just negative x, times the leading term inside here to the 5th power. That is the leading term for that expression. All right, so this is all a product, so these two negative signs are going to cancel each other out because it's not raised to any powers, just to the 1st power. And the rules say we multiply that, so that'll be x to the 10th. And now the rules say that this is going to give me positive 2 times x to the 3 plus 2 plus 1 plus 10. And 3 plus 2 is 5, plus 1 is 6, plus 10 is 16. Now, yet again, in this example, we have a positive number times x to an even power. And so again, we will have up, up, because 2x to the 16th is the leading term of that. Okay, so negative 2x cubed is not the leading term. This is in factored form, and you have to find the leading term. So that was more work. So still, it's going to be up, up. All right, give the y-intercept of the polynomial function. Okay, well, the y-intercept is found when you evaluate the function at 0. So I'm going to take this and I'm going to plug in 0 everywhere I see an x. So negative 2, then parentheses 0 squared minus 1, close parentheses, oops, left out the 0. 0 squared minus 1, close parentheses. 5 minus 0, which will just be times 5, times 0 squared minus 4, then all raised to the 5th. All right, so that's where the y-intercept is, negative 10,240. Now, the instructions say input your answer as a point. So the y-intercept is going to be the point 0, comma, and then whatever that number was, negative 10,240. Then close parentheses. Now I have followed the instructions. I've inputted it as a point. All right, list the potential rational zeros of the polynomial function. Do not find the zeros. Okay, this is the rational zeros theorem. So they all have to be of the form P over Q. Let's see, I can't quite get that on the screen. Okay, so the potential rational zeros of this are going to be of the form P divided by Q, where P is all of the factors of the constant. And so plus or minus 1 and plus or minus 3, and Q is going to be all of the factors of the leading coefficient. So that'll be plus or minus the factors of 11. So I could have plus or minus 1 over 1, plus or minus 3 over 1, then plus or minus 1/11th, and plus or minus 3/11ths. So this is my list. That's going to be my list. Plus or minus 1, plus or minus 3, plus or minus 1/11th, and plus or minus 3/11ths. And that is matching up with this last selection here. So we had to know the rational zeros theorem to do that one. Okay, use synthetic division to find the remainder when that is divided by x plus 1. Input a number as your answer and nothing else. Okay, so let me get this written out. And I want to divide it by x plus 1. Okay. All right, if I'm going to set this up with synthetic division, I'm going to have to put my coefficients of my dividends. So I have 5 times x to the 6th. There is no x to the 5th term, so I've got, that's the same as 0 times x to the 5th. There is no x to the 4th term. I have to put a 0 placement there. I have negative 3 times x cubed. There is no x squared term. There is no x term, but I do have 8. So I have 5 times x to the 6th plus 0x to the 5th plus 0x to the 4th minus 3x cubed plus 0x squared plus 0x plus 8. So I have to represent those zeros there. Now, what goes in the box? It has to be x minus the number in the box. So we don't put 1 in the box. We have to rewrite this. That's the same as x minus negative 1 because it's x minus the number in the box. So I've got to put negative 1 in the box. So when I have that done, I should be okay to go. 5 times negative 1 is negative 5, and then we add. Negative 5 times negative 1 is positive 5, and we add. 5 times negative 1 is negative 5, and we add. Negative 8 times negative 1 is positive 8, and we add. 8 times negative 1 is negative 8, and we add. And negative 8 times negative 1 is positive 8, and then we add. And now when everything's done, that is my remainder. So my remainder is 16. So I'm going to put a 16 in here for my answer, just the number. Okay, so if we look at the next one, use the factor theorem to determine whether x minus c is a factor of f of x. So again, f of x is x to the fourth minus 12x squared minus 64. And the question is x minus 8 a factor? Okay, so what we've got, I'll solve that with synthetic division. Okay, so it's going to be x minus the number in the box, so 8 goes in the box. Then I have 1 times x to the fourth. There is no x cubed term, so that's 0 times x cubed. Minus 12 times x squared. There is no x term, so plus 0 times x, and then minus 64. And so I get the ball rolling this way. 1 times 8 is 8, and I add. 8 times 8 is 64, and then we add. So negative 12 plus 64 is 52. 52 times 8 is going to be 416, and then we add. And 416 times 8 is going to be that. And then we add, which is negative 64 plus 3328. And so this is my remainder. And since my remainder is not equal to 0, then by the remainder theorem, 8 is not a 0. By the factor theorem, x minus 8 is not a factor. So the remainder is not equal to 0, so 8 is not a 0. That's by the remainder theorem. By the factor theorem, x minus 8 is not a factor. So is that a factor? And the answer is no. Okay, find all the zeros of that. Okay, I'm going to look at this on my calculator. So clear out any old rubbish, and let's do x cubed plus x squared minus 2x minus 2. And let's start with a zoom 6. Okay, it looks like negative 1 is a 0. It's an x-intercept, but 1 is not. I can adjust this window if I need to see it a bit better. And let me press graph. Okay, so it does look like it's going through at negative 1. Second graph will give me a table. And I can see that, yeah, we have an x-intercept at negative 1. So negative 1 is a 0. So I get that from the graphing calculator. So p of x is equal to x cubed plus x squared minus 2x minus 2. And from the graphing calculator, negative 1 is an x-intercept. I have an x-intercept at negative 1. And so x-intercepts give me zeros, real zeros. So negative 1 is a 0. So if I do synthetic division with negative 1, I should have a remainder of 0, and I should be able to factor this. One times negative 1 is negative 1, and I add. 0 times negative 1 is 0, and I add. And negative 2 times negative 1 is positive 2, and we add. That's my remainder. That's my quotient. And so now I can rewrite p of x as the divisor, which is x minus the number in the box. So x minus negative 1 times the quotient. That's my constant. That's my coefficient for x. That's my coefficient for x squared. Okay. And this, again, everyone should know that x squared minus a number will factor. So if you've got x squared minus some number k, that always factors as x minus the square root of k times x plus the square root of k. If k is nice, so x squared minus 4 is going to be x minus 2 times x plus 2, because 4 is a perfect square. But it works just as well if k is not a perfect square. So x squared minus 2 is going to be x minus the square root of 2 times x plus the square root of 2. And now that I have p of x in factored form, I can see what the zeros are. The zeros are going to be -1, the square root of 2, and the negative of the square root of 2. Those are 3 real numbers, and we had 3 x-intercepts, but -1 was the one we could easily see. So -1, square root of 2, and negative square root of 2, and that's this one here. All right, so suppose p of x is a polynomial with real coefficients. If 7 minus 2i is a complex 0, what other complex number is sure to be a 0? You take the complex conjugate. And how do you find the complex conjugate? It will also be a 0. You change the sign of the imaginary part. So the imaginary part here is -2. So the complex conjugate of 7 minus 2i is 7 plus 2i. All you change is the sign of the number multiplied by I. So you don't change anything else. All right, find all zeros of this polynomial function. All right, well, let's see if we can find out anything from the graph. So let me clear this and do x to the 4th minus 5x squared minus 36. And let's start with a zoom 6. Okay, it looks like we have -3 and +3 are real zeros. Okay, so because -3 and +3 are x-intercepts, so I can rule out this one. That one's still in the running. That one's still in the running. And I can rule out the other 2. So it's going to be either the second or the third selection. Okay, now I can do the rest of the work with synthetic division. So we have f of x equals x to the 4th minus 5x squared minus 36. And we see from the graph we have x-intercepts at -3 and 3. And so we have zeros of -3 and 3. Okay, so let's break this thing down. Let's first put 3 as our 0. So this is going to be, I could also try and factor this as a quadratic. If I let u be x squared, I could do that. But let's see what I can do with this. I know that 3 is going to be a 0 of this. So I'm going to have 1, but then there's no x cubed term, so I got to put a 0 in there. Then I have -5 x squared. Then there's no x term, and then -36. All right. Now I should be getting 0 when I get that. So 1 times 3 is 3, and I add. 3 times 3 is 9, and I add. 4 times 3 is 12, and I add. 12 times 3 is 36, and we add, and I get 0. So I can write this as the divisor, x minus the number in the box, times the quotient. That's my term for x, x squared, and x cubed. Now, when I looked at the graph, it crossed through at -3 and 3, and it crossed through quite straight. It wasn't stretched out. So I'm thinking that 3 and -3 are zeros of multiplicity 1. So what I'm going to do next is I'm going to do synthetic division on this, and I'm going to try -3 to break this down. So I've got 1, 3, 4, and 12. And I add and get that. 0 times that is 0, and I add. And then 4 times -3 is -12, and I add and get 0. So now I can rewrite f of x as, I'm just copying that, but now I can rewrite this as x minus the number in the box, so x minus -3 times the quotient. And the quotient is going to be x squared plus 4. Now, if you've got x squared plus a number, that will also factor, but not over the reals, but it will factor over the complex numbers. It will be x minus the square root of k times I times x plus the square root of k times I. So these are two common factoring methods that we should know. And this time it's nice because x squared plus 4 is going to be x minus the square root of 4i. And the square root of 4 is nice, it's 2, and x plus the square root of 4i, which will be x minus 2i times x plus 2i. And now, when it's in factored form, it has degree 4, so there will be 4 zeros in total. The zeros are going to be 3, -3, 2i, and -2i. So those are my zeros. Okay, so that's the one I need there. Find all the zeros of this polynomial function. Goodness gracious. Okay, let's look at the graph. So 2x to the 4th minus 11x cubed plus 39x squared minus 43x plus 13. And let's try zoom 6. Okay, so I'm going to need to adjust this window. And let's press graph. Okay, it looks like I have a 0 at 1 and a 0 at positive 1/2. That's what it looks like. Okay, and so all of these are in the running except that one. Okay, I'm going to have to use synthetic division. So it definitely looks like 1/2 and 1 are zeros because I have X-intercepts at 1/2 and 1. So I've got 2x to the 4th minus 11x cubed plus 39x squared minus 43x plus 13. And 1 and 1/2 are zeros, and they look to be of multiplicity 1. They cross through, so they're odd multiplicity, and they're not flattened when they cross through. So they look to be multiplicity 1. Okay, so let's start with the easy one. 2 times 1 is 2. Get that. So I can write f of x now as x minus the number in the box times the quotient. So that'll be 2x cubed minus 9x squared plus 30x minus 13. And now I'm going to try 1/2 with synthetic division on this part. Two times 1/2 is 1, and I add and I get -8. -8 times 1/2 is -4, and I add and I'll get 26, and 26 times 1/2 is 13, and I add and I get 0. So now I can rewrite f of x as x minus 1 times x minus the number in the box times the quotient. Okay, you can factor a 2 out of this, which I might do. If I divide 2 from every term, I'm going to have that. Okay. And I can see that 1 is a 0, 1/2 is a 0, and that's just the constant 2. That'd go out the front. And then I could use quadratic formula to get that 0. So it's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So 16 minus 4 times 13 is negative 36 inside here. And so that's going to be so my zeros are going to be 1 1/2, 2 plus 3i, and 2 minus 3i. And so that's what I need to go back to. 2 plus 3i, 2 minus 3i. But I need to have 1 and 1/2. 2 plus 3i, 2 minus 3i. Okay. All right, find the domain of the rational function. Give your answer in interval form. Well, this is a fraction, and so a fraction is not allowed to be 0 in the denominator. Okay, so see if you can factor it. Two numbers that multiply together give you negative 15, but add up to give you positive 2. Okay, that's what we're going to be. And so when it's like this, we can see x is not allowed to be -5, and x is not allowed to be 3. But it says to give your answer in interval form. So if I look at the number line, I want everything except those 2 points. And then going from left to right, that's negative infinity up to but not including -5. And I have to jump over it, and I want everything in between -5 and 3. Then jump over 3, and I want everything beyond 3. Okay. So that's what I'm going to put in here. Okay. Find the vertical asymptotes of this function. Okay, you have to factor it, and we see that x plus 3 over x squared minus 16 factors as x minus 4 times x plus 4. There is no cancellation, so I have two vertical asymptotes. Their equations are the lines x equals 4 and x equals negative 4. That's what we want. Find the indicated intercepts, the Y-intercept. For the Y-intercept, you replace x with 0 and then see what you get. So I'm going to replace x with 0, so I get negative 1 squared in the top, and in the bottom I get 0 plus 11 cubed. Negative 1 all squared is 1, and then 11 cubed is 1331. So my Y-intercept is the point 0, 1 over 1331. Okay. Find the X-intercepts. Okay, the X-intercepts are found at zeros of the numerator after any cancellation. And so I've got x cubed minus 8 all over x squared minus 25. And I know that x squared minus 25 is x minus 5 times x plus 5. X cubed minus 8, let me just look at that and see how that will factor. So x cubed minus 8, and do a zoom 6 with that. And I can see that positive 2 is a 0 of that. So I've got 1x squared times 1x cubed times 0x squared times 0x minus 8. And so x cubed minus 8 is equal to x minus the number in the box times x squared plus 2x plus 4. And I bet that doesn't have any zeros, doesn't have any real zeros. Let's look at x squared plus 2x plus 4. Okay, so it doesn't have any real zeros because it doesn't have any x-intercept. So this has no real zeros. So there is no cancellation. This has no real zeros, and so I only have one real zero in the numerator, and it's at 2. And so I'll have an x-intercept at 2, 0. All right, do we have a horizontal asymptote here? Well, the degree of the numerator is 4, and the degree of the denominator is 4. So there were a couple of cases you had to know. When the degree of the numerator is the same as the degree of the denominator, then you do have a horizontal asymptote, and its equation is going to be y equals a fraction, and in the top we have the leading coefficient of the top, which is a 7, divided by the leading coefficient of the bottom, which is an 8. And in this one we just make double sure that yeah, they were given in descending order, so I didn't have, you know, a higher power of x here written out of order. Okay, and so it has to be an equation. It is a horizontal line. So the horizontal asymptote is the line with equation y equals 7/8, and right here it tells you how to input a fraction, 7/8. Okay. Find the equation of the oblique asymptote. Is there an oblique asymptote? Yes. The numerator has degree 2, the denominator has degree 1, so we do have an oblique asymptote, and it will be y equals the quotient will be our equation. Now, we can use synthetic division with this. I don't have to use long division with this. So it's, if I'm going to set this up with synthetic division, it's x minus the number in the box. So I'm going to have to rewrite that as x minus -7. And then I have a 1, a 5, and a 3. 1 times -7 is -7, and we add. And -2 times that is +14, and then we add. Now, that's the remainder. These give me my quotient. So there's the constant, and that's my coefficient for x. So the equation for the line, which is the slant asymptote, is y equals the quotient. And in this case, it's going to be y equals 1 times x plus -2. That is the equation of my asymptote. So y equals x minus 2. Okay. Find the hole in the graph. All right, well, let's see if there is a hole. I've got x squared plus 4x minus 5, and then I have 2x squared minus 5x plus 3. Okay, I would like to factor those. The numerator will factor quite easily. Two numbers that multiply together to give me -5, but add up to give me +4. That will be +5 and -1. Okay, now to factor that, I might want to take a look at the graph. So let's see what the graph of 2x squared minus 5x plus 3 looks like. Okay. All right, let's see. Okay, it looks like I have an X-intercept at 1, and so 1 is a 0. So I can use synthetic division on that to factor it. 2 times 1 is 2, and I add and get that. So 2x squared minus 5x plus 3 is going to be equal to x minus the number in the box times the quotient. That's the constant, and that's the term for x. All right, I've got it factored. All right, now we do have cancellation here. The x minus 1's cancel. So I've made this cancellation, understanding that x is not allowed to be 1. Now, where is the hole? The hole will have x coordinate 1, and then the y coordinate will be when we plug 1 in to the canceled equation. So the hole's going to be at 1 comma, the top's going to be 6, and the bottom's going to be 2 minus 3, which is -1. So the top's going to be, 6 over -1 is -6. So that's where the hole is, 1 comma -6. Okay. All right. A patient is given a drip feed containing a particular chemical concentration. The doctors believe a linear relationship exists. What will the concentration of the chemical in the blood be after 4.5 hours? So if X is 4.5, what is Y? Round your answer to 2 decimal places. Okay, so I'm going to need to clear that. And then I'm going to need to clear out 2 lists. Okay, and so over here I'm going to have my X row. And over here I'm going to have my Y values at 2.4, 4.3, 5.0, which is just 5, 6.9, 9.1, 11.4, and 13.5. Just do a quick check. All right, and I'll do stat, go to calc, and we've been told it's linear regression. I use list 1 and list 2, so I can just press enter. And so that's going to be my equation. So I'm going to go over to y equal. I'm going to do vars. And that. And it appears there. And now I'm going to do second y equal. And I just want to have a look at the stat plot. I'm going to do zoom 9. Okay, that's really good. Now, what is the concentration of the chemical in the blood after 4.5 hours? So I'm going to do second trace, and I want a value, and my X value is 4.5. So it's going to give me the point whose X coordinate is 4.5. The Y coordinate will be the answer. Round your answer to 2 decimal places. That's what the instructions said. So if I cut that off at 2 decimal places, that 8 is going to bump that up. So it should be 10.28. Okay. Avery recorded the distance and height of a ball when shooting a free throw. Look at the scatter plot and you decide what type of regression to use to find the height of a ball at a distance of 7.5 feet. So if X is 7.5, what is the Y value going to be? Okay, so let's clear this out. And again, let's clear out list 1 and list 2. Okay, so let's go to list 1, 0, 2, 6, 9, 12, 13, and 15. And then we come over here and we have 4, 8.4, 12.1, 14.2, and 13.2, 10.5, and 9.8. Now I'm going to check these pairings before I go on. 9.8 and 15, 10.5, 13, 13.2, 12, 14.2 and 9. Okay, and 4 and 0. Okay. So now what I want to do is I want to go to second y equals, enter, and I want to turn the plots on, and I want to scatter plot, and list 1 and list 2 are our default, so I'm going to do zoom 9. Okay, that to me looks like it wants to be a parabola. So that means it wants to be quadratic. So I'm going to do quadratic regression. And just press enter because the default is list 1 and list 2. So y equals, press vars, go there, then go to there, then enter. Okay, so now I want a second trace, and I want to get a value. Okay, and so when x is 7.5, what is the height? All right, now round your answer to 2 decimal places. Okay, if I cut this off at 2, that 4 here will not change that 2, so it's going to be 13.42. 13.42. And then finally, use a graphing calculator to approximate the real zero of this. Okay, there was a video on how to do this, and it was made clear. It was mentioned more than once that there aren't any web work problems like this, but there's always one like this on the final. So we have to know how to do this. I'm going to enter this in my calculator. I'm going to start with a zoom 6. Okay, so I need to know where that is. So I'm going to do second trace, which will give me calc, and I want to get the X-intercept, which is the 0, the real 0 there. Now it says it wants a left bound. So where is, this is showing me where that's at, and it's a negative number, and so it is to the left. I need to come out here. There's that little ball. Okay, I need to get this ball as close to the 0 as possible, but it needs to be to the left of it. So if I do that, that's gone too far. So it needs to be just to the left of where it crosses the x-axis. Enter. Now a right bound. Okay, and that is to the right of where it does. So enter. Then it says, do you want me to guess? Yes, I do. So enter again. So the 0 is going to be, the x-intercept is going to be at that x coordinate in 0. Now, how many decimals does this take it to? It takes it to 4 decimal places. 1, 2, 3, 4, and that 4 there does not change that. So 1.0938. Okay, and so that ends this version of test 2. Okay, so let me just make clear, when we did this one, number 7, I actually got the zeros correct on paper. All right, but then when I went to pick these out, I chose the wrong one. I was looking at the square root and negative square root, so it should have been that one. We actually got that one correct on paper, as you can see, but I just made a mistake there and chose the wrong one. Other than that, there aren't any errors. Okay, so sorry about that, but the calculations were done correctly on the paper. Okay,